Welcome to our math lesson on solving exponential and logarithmic equations. These types of equations appear frequently in calculus, physics, and many real-world applications like compound interest, population growth, and radioactive decay. Today, we'll learn how to solve both exponential equations, where the variable appears in the exponent, and logarithmic equations, where the variable appears inside a logarithm function. We'll explore several step-by-step strategies with clear examples to help you master these important techniques. Let's start with exponential equations, where the unknown variable appears in the exponent. Here are some examples of exponential equations. Notice how x appears in the exponent in each case. We have three main strategies for solving these equations. The first strategy is to match the bases when possible. If we can rewrite both sides with the same base, we can simply equate the exponents. Let's see this in action with our first example, 2 to the power of x equals 16. First, we notice that 16 can be rewritten as 2 to the power of 4. Now, we have 2 to the power of x equals 2 to the power of 4. Since the bases are the same, we can equate the exponents x equals 4. And just like that, we've solved our first exponential equation. But what if we can't easily match the bases? That's where our second strategy comes in, using logarithms. When bases cannot be matched, we can take the logarithm of both sides and use the power rule of logarithms, which states that the log of a number raised to a power equals the power times the log of the number. Specifically, log of a to the power of b equals b times log of a. Let's apply this to our second example. 3 to the power of 2x minus 1 equals 5. First, we take the natural logarithm of both sides. Now we can use the power rule to bring down the exponent. Log of 3 to the power of 2x minus 1 equals 2x minus 1 times log of 3. This gives us 2x minus 1 times log of 3 equals log of 5. Solving for x, we get 2x equals 1 plus log of 5 divided by log of 3. And finally, x equals 1/2 times 1 plus log of 5 divided by log of 3. Our third strategy is for equations with different exponential terms, like 5 to the x equals 2 to the x plus 3. Let's solve this example. We start by taking the natural logarithm of both sides. Applying the power rule, we get x times log of 5 equals x plus 3 times log of 2. Now we distribute and collect the terms with x times log of 5 equals x times log of 2 plus 3 times log of 2. This gives us x times the quantity log of 5 minus log of 2 equals 3 times log of 2. Finally, x equals 3 times log of 2 divided by log of 5 minus log of 2. Now let's move on to logarithmic equations, where the unknown variable appears inside a logarithm. Here are some examples of logarithmic equations. Notice that in each case, the variable x appears inside the logarithm function. Our first strategy for solving logarithmic equations is to convert them to exponential form. Let's see this with example 4. Log base 2 of x minus 1 equals 3. Remember the fundamental relationship between logarithms and exponents. If log base b of a equals c, then a equals b to the power of c. Applying this to our equation, we convert x minus 1 equals 2 to the power of 3, which is 8. So x equals 9. Simple and elegant. Our second strategy for logarithmic equations is to use logarithm rules to combine or separate terms. Here are the key logarithm rules you need to know. Rule 1. The logarithm of a product equals the sum of the logarithms. Rule 2. The logarithm of a quotient equals the difference of the logarithms. Rule 3. The logarithm of a power equals the power times the logarithm. Let's apply these rules in example 5. Log of x plus log of x minus 3 equals 1. First, we use rule 1 to combine the logarithms on the left. Log of x times x minus 3 equals 1. Next, we convert this to exponential form. X times x minus 3 equals 10 to the power of 1, which is 10. Now, we have a quadratic equation, x squared minus 3x equals 10, or x squared minus 3x minus 10 equals 0. Factoring this, we get x minus 5 times x plus 2 equals 0. So x equals 5, or x equals negative 2. However, we need to check our domain restrictions. For logarithms, the arguments must be positive. 4x equals 5. Both x and x minus 3 are positive. So this works. 4x equals negative 2. X minus 3 is negative, which is outside the domain of logarithms. So our final answer is x equals 5. Our third strategy is for when logarithms appear on both sides of the equation with the same base. In this case, we can equate the arguments of the logarithms directly as long as both arguments are positive. Let's apply this in our final example. Natural log of 2x plus 1 equals natural log of x squared minus 3. Since we have the same logarithm base on both sides, we can equate the arguments directly. 2x plus 1 equals x squared minus 3. Rearranging to standard form, x squared minus 2x minus 4 equals 0. Using the quadratic formula, x equals 2 plus or minus the square root of 4 plus 16, all over 2. This simplifies to x equals 1 plus or minus the square root of 5. Now, we check our domain restrictions. 4x equals 1 plus square root of 5, which is approximately 3.23. Both logarithm arguments are positive, so this is a valid solution. 4x equals 1 minus square root of 5, which is approximately negative 1.24. The argument 2x plus 1 is negative, so this is not a valid solution. Therefore, our final answer is x equals 1 plus square root of 5. Let's review the key points to remember when solving exponential and logarithmic equations. First, always check domain restrictions before accepting solutions. Logarithms require positive arguments. Second, use logarithms to bring down exponents in exponential equations. Third, convert freely between logarithmic form and exponential form as needed. Fourth, combine logs when you have sums or differences on one side. And fifth, when bases match on both sides of an exponential equation, equate exponents directly. With these strategies, you can tackle virtually any exponential or logarithmic equation. Remember, practice is key to mastering these techniques. Thank you for watching.